In today's video, we'll see some more complicated versions of the chain rule. In our first example, we're going to work with a e case. Keep in mind, e to the x, plain old e to the x's derivative is just itself. So here, the e to the x part, that's our outer, and the square root of x, that's our inner. So when we take the derivative, our outer, e's derivative is just itself, so we'll just have e to the square root of x. Because remember, you keep the inside function the same. Times derivative of the inside function. Well, remember, square root of x is the same as saying x to the 1/2. So our derivative of the inside part would be 1/2 x to the minus 1/2. And that would be our derivative using the chain rule. So we've got a product rule going on here. So we'll do derivative of the first. So you've got 5 times 2x plus 1 raised to the 4th times the regular of the second, which would be x cubed. Oops, actually, hold on. We still got to do times derivative of the inside, which would be 2. Times regular of the second, which would be x cubed minus x plus 1, all raised to the 4th, plus, because it's product rule. We'll do regular of the first, so 2x plus 1 raised to the 5th, times derivative of the second. So we'll have the 4 out front. We'll have x cubed minus x plus 1, now raised to the 3rd, times derivative of the inside, which would be 3x squared minus 1. And again, if you wanted to neaten that up, you could. You could multiply the 5 and the 2 together. We could bring the 4 out front there if we wanted. But if it doesn't say to do so, I would say just leave this as your final answer. We've got another e case. Again, remember, e is our outside and sine x is our inside. Now, sometimes people have trouble deciding what's your inside, what's your outside. Well, your inside should be where there's normally a plain old x. We normally see e to the x. So that means sine x has replaced that plain old x there, making it the inside function. So think of it as where is there normally a plain old x, and that's what your inside function is. So when we do our derivative, we'll have e to the sine x. That's our derivative of the outside function, keeping our inside function the same, times derivative of the inside. Well, derivative of sine x is just cos x. And that is our derivative, having used chain rule. Now, we've seen that the derivative of e to the x is just e to the x. What about when it's some other base other than e? In that case, we would have that base raised to the x times ln of a. So if you have 4 to the x and you want the derivative, it would be 4 to the x times natural log of 4. If you have 7 to the x, your derivative would be 7 to the x, natural log of 7. And the reason this matches up with our e to the x, remember d dx just means take the derivative, that would be e to the x times ln of e. Well, e to the x is just 1, so it's e to the x times 1, which gives you e to the x. So we would, in fact, just get our regular e to the x rule back if we applied this with a base of e. But this actually works for any base a. So just to see if we can apply this, if we had 2 to the x, our derivative would be 2 to the x times natural log of 2. And that would be your derivative right there. Okay, now some more complicated chain rule examples. Here we're going to have double chain rule. Sine is our outsidemost function. We now kind of have, we'll call it our middle function, and then tan is our inside function. So remember, when we do normal chain rule, we do derivative of the outside, keeping the inside the same. So we'll start out, we'll do derivative of the outside, which would be cos x, or just cos actually, keeping the inside the same. Well, now we got to do derivative of the inside. Well, the inside of our outermost function is this here. So we've got to do the derivative of cos tan x. Well, the derivative of cos tan x is a chain rule in itself. So we'll take the derivative of cos, which is negative sine, keeping the inside the same, keeping the tan x the same, times the derivative of our innermost thing now, which would be secant squared x. So we basically got double chain rule, because the inside function is a chain rule case in itself. Okay, here again, we've really got chain rule within chain rule. E is our outermost function. Secant we can think of like the middle function, and 3 theta as the insidemost function. So start with derivative of your outermost thing, which is an e. We know derivative of e is just itself, so we'll have y prime is equal to e to the secant 3 theta times derivative of your inside. Well, that means we're doing derivative of secant 3 theta. So in that, secant is the outermost function, so we'll do derivative of secant, which is secant tan. Now, when you do that, remember you keep the insides the same. So when we do secant tan, we'll have to have secant 3 theta times tan of 3 theta. Now, we've still got to do times the derivative of the 3 theta, because that was the innermost thing. Well, theta is like your variable, like an x, so derivative of 3 theta would just be 3. So if when you take the derivative of like an outermost part, like our secant, and there's multiple parts to it, anywhere where there would have been an x needs to be replaced with what's on your inside. So in this case, a 3 theta had to go in both the secant part and the tan part. And again, you could neaten this up if you wanted, but I would suggest just leave it as is if all they want is the derivative. Okay, another example. Our outer is the 2 raised to something. You can think of like your middle function as the sine and your innermost as the pi x. So start with your derivative rule for the outermost part. Well, normally it's 2x ln 2, but we'll have 2 to the sine pi x times natural log of 2, because it's natural log of the base, times derivative as we work our way in. So derivative of sine would be cos, keeping the pi x the same. Now times the derivative of the pi x, which is just pi. And these, again, are by no means easy when you've got multiple chain rules going on. Again, start with the derivative of the outermost thing, working your way towards the middle, doing the derivative of all the inside things. Another example with something with a base other than e, we'll have a base of 2 again. Remember, your rule is for the basic 2 to the x is 2 to the x ln 2. So we'll have y prime is equal to 2 to the 3 to the x squared times ln 2. We'll now do derivative of this, derivative of 3 to the x squared. Well, that's another exponential, so it'll be 3 to the x squared times ln 3. Well, now we got to do derivative of the x squared, which is 2x. So we did derivative of our outermost thing, keeping the inside the same. That rule had a times ln2 in it. Derivative of our next outermost thing, the 3 to the x squared, is 3 to the x squared times ln3. And then we had to take derivative of the x squared. That's all for today's video. We'll see you next class period.